All right, fellas. So this is an introduction to matrices, and hopefully this is a review topic for you. If it's not, then we'll go over some of the basics. I'm going to kind of hit these things real fast, and then we'll get into what we can do with matrices. I guess the beginning of what we can do with matrices. So first and foremost, a matrix is just an array or a collection of objects that may or may not be related to one another. All right, they have dimensions, and when we list a matrix, we list it rows by columns. So we would say a 2 by 3 matrix. Rows go left and right. Columns go up and down. All right, I don't know why, but this is always something that helped me remember which was which. Rows go left and right, columns go up and down. So when we list it, we always list it rows by columns. Okay, a couple things as far as notation goes. We're looking at determinants of matrices, and determinants have are nice, useful tools for us. Hopefully you learned how to take determinants last year, but a couple different notational things about determinants. Number one, the determinant of A means that you are taking the determinant of some matrix called A. A is just the name, whatever you called A. So you would say, hey, let A equal this matrix, and if you see this notation, determinant of A, that means go find the determinant. You also might see something to the effect of this. If it just has straight lines on the outside, almost like an absolute value of a matrix, A, B, C, D, E, F, G, H, I, this means also the determinant. This means find the determinant. All right, so that is a little thing that you need to kind of pay attention to. Traditionally, matrices have these square brackets around them, but if you see one with straight sides to it, that is notation for find the determinant of that particular matrix. Finding determinants, guys, you can only find the determinant of a square matrix. And by square matrix, we mean same number of rows and columns. Okay, we can only find the determinant of a square matrix, a matrix that has the same number of rows and columns. If we want to identify elements, this element right here would be called A11, and again, it is rows and columns. Okay, so this means, hey, I want the first element in the first row in the first column. That's going to be equal to X. The element in the, let's say, the third row, second column would be equal to Y2. Third row, 1, 2, 3. Second column, move over 1. That's how we can identify elements. All right, so A11 means, hey, what's the first element, or what's the element in the first row in the first column where these two intersect? All right, next thing we want to do is just review, how do we find determinants? So this is a 2 by 2 matrix. This is the nice easy one. What we can do in a 2 by 2 matrix is we can take the upper left and multiply it by the bottom right. In this case, it would be A11, multiply it by A22. So we would say X1 times Y2. The next thing that we do is we subtract the other cross product. Okay, so we would multiply, or we're looking at the difference between these two elements and these two elements. That's how we can find the determinant of a 2 by 2 matrix. One other little detail, guys, a determinant is always a scalar. It's always a number. It is always a number. All right, we'll look at different properties of what kinds of numbers are indicative of what kinds of situations, but the determinant is always a number and it's really the difference of products. All right. Determinant of a 3 by 3. Again, hopefully this is review for you. If it's not, pay close attention, and we'll work with it over the next couple days. Here's what we do. Basically, what we're going to do is we are going to look across this top row, and we're going to say, hey, I'm going to take this element right here, and I'm going to cross off everything in that row and that column. Okay? So I've got X, and what I'm going to do is I'm going to take the determinant of the remaining 2 by 2 matrix. Okay, so I'm taking X, I want the product of this element up here, multiplied by the determinant of Y1, 1, Y2, 1. I'm next going to subtract. We'll change colors, hopefully this will help you keep organized. I'm going to next subtract the next thing, the next product. So my next product is Y. Again, we're going to eliminate that row and that column and take the remaining 2 by 2 matrix. So what's remaining? We've got the determinant of X1, 1, X2, 1. And lastly, and we're getting a little ugly here, but hopefully you guys get the gist. I'm going to take this element up here, cross off the row and the column, and take the remaining. And this time I'm going to add. This is actually the process for any matrix, not just a 3 by 3. This is any matrix. Notice that we're alternating signs. And we can do this with a 4 by 4 or a 5 by 5. And again, just to reiterate, we can only take the determinant of a square matrix. So just to finish this up, we've got X1, Y1, X2, Y2. So this would be the determinant of matrix A. Equals this big long thing. Well, let's go ahead and simplify. So the determinant of A is equal to Y1 minus Y2. So this is X times Y1 minus Y2 minus Y. The determinant of this is X1 minus X2 plus 1 times X1 Y2 minus X2 Y1. Alright, so we've got it in this form. Basically, hopefully at this point you kind of start to see some of the pieces fall together and they look a little bit familiar. What we're looking at really is if we move our Y over here, so we've got Y times X1 minus X2 equals X times Y1 minus Y2 plus all this stuff over here. Well, essentially, if we just simplify a little bit and divide by X1 minus X2, we've got Y equals X times Y1 minus Y2 over X1 minus X2, which is slope, plus X1 Y2 minus X2 Y1 over X1 minus X2. And you can't simplify this any further, but basically that's your y-intercept. So the point in all of this is that if we can write, if we have a couple points, and let me clear this out so you can see it a little bit better, but if we have a couple points that are given to us and we put it in this determinant form, what we can do is find the equation of a line by finding the determinants of the coefficient matrix, what we call a coefficient matrix. So we just set up this matrix, this 3 by 3 matrix, based on The points that we're given, the x and the y are arbitrary. I'm sorry, not arbitrary. They stay x and y. The rest of these are just points. So let's look at an example real quick. Use determinants to find the equation of the line that passes through these points 3, -2, 9, 5. So what we're going to do is we're going to set up and we're going to say, hey, let matrix A equal 3, -2, and 1. Nope, that's not right, sorry. We're going to start with our x and our y. So x, y, and 1. Now 3, -2, 1, and 9, 5, and 1. We're going to let A equal that. Why the 1s? Well, we know that the equation of the line is going to look like this. Okay? So when we set this equation up, we want to go ahead and look at something that's in this particular form. So if we let A equal that, then we can find the equation of the line that passes through these 2 points using, or by finding the determinant of A. So again, we know it's got to be equal to 0. So 0's got to be equal to x times -2 minus 5. That's here. Y times 3. I'm sorry, minus y times the quantity 3 times 1 minus 9 times 1. So 3 minus 9. And then plus 1 times the quantity 3 times 5 minus 9 times -2. So my equation ends up simplifying to -7x plus 6y, and this simplified here is going to give us 18 and 15, which is 33, plus 33. If we want to write it in a different form, we can, or we can keep it in the standard form, and that's the equation of our line.